All right, guys. Um, so I think it was a couple days ago I shared with you guys that quadratics can be written in two different forms, standard form or vertex form, and I think it was yesterday that we dealt with this and how to graph it, things like that. So today we're going to look at ones that are drawn like this, or not drawn, but written, and then we're going to transform it into this form. It's analogous to, you guys remember these? Right? I gave you equations like this before, and we would change it into slope-intercept form. Remember that? It's the same idea. So why did we change it from this form to this form? Because it's easier to graph in, right? So same thing here. You want to be able to transform them because it's helpful for graphing. But honestly, I'm going to teach you guys how you can graph from here anyway. So what's another reason? Well, you guys know the quadratic formula that we messed around with? That actually comes from changing this into this and then solving for x. Every once in a while I'll make that an extra credit question. I might throw that at you guys and I'll show you how to do it, and you can do it on the test. It's very lengthy. Yeah, of course. It's a good skill. Also, changing it from standard form into this form is helpful in a variety of other applications. Later on in the year, we use it for these things called conics, and we use it also in calculus. So it's a cool strategy, actually. And I think what's kind of neat is, the neat thing about it that makes it so functional is, you guys see how we have two x's here? But when you change it into this form, you only have one x, and that kind of makes things easier when you're trying to like solve or whatnot. So it's a good skill, and it's pretty practical, so it's worth spending a day on to kind of get you guys to know how to change into vertex form. So we have talked about the two forms, haven't we? Or I don't know, because I kind of double teach, like Algebra 2 is doing similar stuff to you guys. So we've talked about these two forms, have we? Oh, okay. I got one nod, maybe. So anyway, there it is. Did I print this for you? Okay. So we'll just move on. All right, so let's talk about what a perfect square trinomial is. Before I do, let's talk about what a perfect square is. 64 is a perfect square. Why is it a perfect square? Because you can write it as 8 squared, right? That's a perfect square number. 25 is a perfect square, right? Something like 63 is not a perfect square. It doesn't mean there's not an answer to that. It's just that you end up with a weird irrational number. Okay? Now there's a way that we can change things so that it is a perfect square. Like, for instance, if I want this to become a perfect square, I would just have to add 1 to it, right? And so that's kind of like what we're going to do today. We're going to start off with a trinomial. Well, let me back up a little bit. So first of all, let's talk about perfect square trinomials and what those are. This is a trinomial, and it's a perfect square trinomial because when you factor it, I'm going to try to move this down a little bit so people in the video can see. When you factor it, you get the same thing twice, right? And you would end up with, therefore, x minus 5 squared. So that's a perfect square trinomial because it can be written as a square. Now, in the interest of time, I don't think I really want to review factoring with you guys, but I do want to show you guys a cool shortcut. Ready? This is something worth writing down, I think. So here's the example you guys had in the last slide, right? Well, if it's a perfect square, now this only applies to perfect squares, okay? So how do you know if it's a perfect square? Well, by the end of the day, you're going to know when it's a perfect square, so you don't have to worry about that too much. But if you have a perfect square trinomial, here's how you can just jump right to the answer. It's always going to result in something squared. We know that, right? And the first number is always going to be x. The only thing we have to wonder about is what number goes here. Okay? And it just so happens that it is exactly half of that middle number. So that would be minus 5. So you had a nice shortcut. You don't, I don't think we've done much factoring in here yet this year. We will, but a lot of teachers teach it with the box method. Remember that? Or reverse FOILing, things like that. And that'll work here, but we're going to use a shortcut because today we have these perfect square trinomials, and we're just going to use a shortcut to make things go by quicker. Okay, so why don't I throw one at you guys and see if you guys can figure out what it would be. Now I'm going to tell you this is a perfect square trinomial. You might not be aware of that fact yet, but for now I'm going to tell you that this is in fact a perfect square trinomial. If you were to factor it, what would you get? So go ahead and see if you can finagle that real quick. What do you think? What did you get? That is right. Okay, so we're just going to use that little shortcut today. So if you remember, it's going to be something squared. X is always in the front. The 3 comes from taking half of the middle number. That's our shortcut we're going to use today. Yeah, got it? Good. All right, let's move on to bigger fish here. No, it's half the middle number. Although I think that would be true, but it's possible that they could both be divisible by more than one thing. And so the safest bet is just say take half the middle number. That's how you're going to do it. So half of negative 10 is negative 5. That's how you want to find it. All right. So completing the square is, I'm sure you guys saw this in Algebra 2. It's not something you remember because it's not something you do every day. But completing the square is a process that you go through to change a trinomial into a perfect square trinomial. The process you go through to change a regular old trinomial into a perfect square trinomial. It's like getting married, right, ladies? You marry an imperfect guy, and you make him perfect. You make him into what you want him to be. That's what we're going to do today. And guys, we don't have to worry about that because ladies are perfect. Steve is. Thanks, sir. All right. So, I'm going to back up for a second here, if I can. Please. Pretty good. I know what I'll do. I'll push backspace. All right. So I want you guys to notice something here. Ready? So remember how I told you this number is half the middle number, right? What do you notice about this number? It's basically that number times itself, right? Okay. So here's now we're going to reveal the secret. How can you tell if something's actually a perfect square trinomial or not? Well, if you take half of this number, which is what? Negative 5, and square it, that's what you should have right there. If it has that relationship where half this number squared is that number, then you have a perfect square trinomial. If it's not, then you don't have a perfect square trinomial. So let's jump back over here. I wanna create a perfect square trinomial. That's my goal here. So go ahead and write down example 1. We want to make this. We want to force this thing to be a perfect square trinomial. So the first thing we're going to do is we're going to take half of this number. So I'll put half there. What's half of 8? 4. It's 4. Then we're going to square it. 4 squared is 16. That's the number we're going to put right there. Okay? So I've forced it to become a perfect square trinomial. And now we could use our shortcut to factor it. Okay? So it would be x plus something squared, right? And that something would be half of the middle number. You don't have to write that part, but I'm just showing you could factor it if you wanted to. Okay? So this part I'm not too worried about. We already practiced that. I want to make sure you guys got this, though. Half the middle number squared is what you're going to put here to make it become a perfect square trinomial. Okay? I'll tell you why we're doing all this in a minute, but for now, let's practice it. See if you guys can figure out what mystery number goes there. So we take half of the 12, which is 6, and we square it, which gives us 36, and that's what we're going to drop down there. Okay? And so that's completing the square. And if, once again, if you wanted to factor it, which eventually we will, it's always going to be x plus something squared. In this case, the something would be 6. Okay? So now why are we doing this? Now take a look at this. You guys see that format there? Why are we going through all this trouble? I will show you. Remember our goal for today was we wanted to change something from this form, right? Doesn't that kind of look like the ones we're working on right now? Into something of this form, and look at that little piece right there. Doesn't that looks familiar now, right? So that's the goal, is somehow we want to force this to become a perfect square trinomial so we can get that little chunk there that we need so that it has the proper format. All right, so all that fun stuff being said, let's continue our journey here. So now we get to do the real problem for the day. We're going to actually take something in standard form and change it into vertex form. And now that we've got all the tools in place, we're going to pull it off. But it's a very lengthy process. It takes about 6 steps of algebra maneuvering to get there. Maybe less, maybe like 4 or 5. Go ahead and write it down. You're going to need some space. I would also encourage you that as I do this, I'm going to write down some verbal steps on the side. I would encourage you to write those down as well. Okay, let's do it. So we had, we had 2x squared, was it 12? Plus 13. Okay. So I'm going to call this number here what we called it yesterday or 2 days ago, the A. I'm going to call this the B, and I'm going to call this the C for my steps that I'm going to be going here. I'm going to name those letters, so just be aware of what I mean when I say A, B, C. All right, so the first thing that you're going to do, step 1, is you're going to move C to the other side. Move the C to the other side. Okay, so here's what that's going to look like. This is my C, right? So I want to move that over to the other side. How would I do that? You're going to subtract it. And that gives me this. So that's your first step, is to move the C to the other side. Why would we do that? Remember, we're trying to complete the square, and usually the number that's a problem is that last number that's in our way, so we need to get rid of the one that doesn't work for us so we can create the number that we do want. So we're going to get rid of that third number there. All right, the next thing that we're going to do is we're going to factor this number here in front. We're going to take that out, because notice in all the examples we had was just an x squared in the front. Well, we don't want that 2 there. I need to pull that out. We need to factor it out. So let's write down that. So we have, I'm going to take out the 2. Well, you have to divide everything by 2, which you could, right? This divided by 2 would be x squared. This divided by 2 is 6. So before I answer your question, let me finish this, and then I'll show you why. Now, if I take out the 2, what's going to be left inside here? X squared. So if I divide this by 2, I get x squared. If I divide this by 2, I have 6x. Okay? So the step is to factor out the a. Factor out a. So step 1, move the c to the other side. Step 2, factor out the a. So now to answer your questions, Anna, remember our goal for today is to change it from standard form to vertex form, right? So I want to show you something here. I'll go back for a second. Notice that I want to go from here to here, right? Look at that A. See where it's at? So we want it to be there. We don't want to divide it to the other side. We want it factored out, but we don't want it on the other side. Does that make sense? All right. So that's why. Okay, next step. Next step is the magic step. I want to make this thing become a perfect square trinomial. I want that thing to become a perfect square trinomial. How do we do that? We complete the square. All right. So what number goes here, guys? Take half first, and then we square it, which would be 9. And so the answer is 9. So we want to complete the square. Okay, now, fourth step. We're getting there. We're not there yet, but we're getting there. I just did something illegal, though. I have an equation, right? I've got the right side, and I've got the left side, and I just added something over here, right? What happened to my balance? I just made it unequal. So now by putting a new number in here, this is no longer equal. They're not actually equal anymore. I changed it. But they will be equal so long as whatever I do over here, I do over there. Now there's a little bit of a trick here, because some of you guys might think just add what? 9, but that's not it. Does anybody know what we should add over there? 18. The heck? Why 18? Because that 9 is being multiplied by 2. Now, if for those of you guys having difficulty tracking that, I'm gonna show you a step that'll kind of at least you'll have something to look at in the future. So let's add a next step here. So we have, right now we have 2x squared plus 6x plus 9, right? Equals y minus 13. So I'm going to call this step fix the balance. Am I in step 5 or 4? So I'm going to call this fix the balance. Okay, and here's how we do it. So remember how I put this 9 in here, right? So but what do we do to one side? We have to do to the other. Now by putting 9 in here, though, I didn't really just add 9 to this side because everything in here is being multiplied by 2, right? So by putting 9 in there, I really added 18 to the left side of my equation. So here's how we're going to show our work here on our notes so that we know what's going on. We're going to multiply this. So what's 2 times 9? 18. And then we're going to add that over there. So we really that'll fix our balance. Yeah. What else would you do? So remember we have a balance, right? And you agree I added 9 times 2, which is 18, right? So if I want to stay balanced, if I add 18 over here, I have to add 18 over here. Now some teachers teach this a little bit differently. Maybe you're remembering Algebra 2 last year. Some teachers don't move the 13 over here in the beginning, and what they do is they do everything on one side. In that case, you actually do a plus and a minus one. But the way I'm going about it, we just add it on both sides. So I don't know if maybe you're remembering stuff from last year, but that's how we're going to do it here. Yeah, okay. Okay, yeah. Mm-hmm. Yeah. You're right, you're right. I know what you're talking about, yeah. I know what you're talking about. I might be able to refresh you on that if you like. Okay. Anyway, I'm gonna go ahead and finish this here. So we're almost there. We're getting close. The next thing we want to do is we want to factor this. We want to factor that. Now you guys already know how to do that, right? If I factored that, it would turn into what? It's a perfect square trinomial, so we got a shortcut for that. X plus 3 squared. I'm also going to say go ahead and just combine these together in this step. It's pretty simple. What's negative 13 and 18 make? So we're just going to put 5 there. So it's 5. I'm just going to call this factor. And simplify. We're getting there. All right, last step. Last step. We want the y by itself, right? So the last step is just to move the 5 back over here. And then we're done. So minus 5, minus 5. So that's my last step. Let's write that down. At this point, we're going to say move the k to the other side. Notice I call it a k. Do you guys see why I'm calling that a k? Because Well, so yeah, it is a constant, but also because when you're in vertex form, this number right here, remember it's A, H, and K. So now that's our K. That's part of our vertex now, right? So there it is. All right, so we're going to do a student practice to kind of walk you guys through it, or a guided practice. But that's your steps. It's a 6-step process, and that you guys can see now why I was encouraging to write some verbal notes as you went, because it's quite lengthy. So now Xana was talking about a formula. There is a formula. How many of you guys learned a formula for this last year? Anybody? Okay. There is a formula. It makes it really simple. It does. The reason I don't teach the formulas, first of all, remember the extra credit I told you I was thinking about giving you where you change, it's where the quadratic formula comes from? If I don't show you this, the extra credit would make sense. Second of all, that formula you're using to get this comes from this process. So somebody just did all the work for you and turned it into a formula. So it's easier, right? But I want to teach you guys why things are. And then the third reason is because in future applications of this stuff, that won't work anymore. So you kind of need to have, I like just to teach the foundation. But the formula is faster, and so if you want, I can refresh your mind on it, and you can use it for this test if you like. But let's go ahead and let's do one together. So this is a guided practice. That means we're going to do it step by step together. Now hopefully you guys took good notes, you wrote down your steps, so I'm just going to say do step 1, and I'm going to ask you what you got. Okay? And if you forgot step 1 is, look back at your notes and see if you can figure that out. So go ahead and do step 1. Try, Edward, what did you get? Very good. And he told me the step 2. The step is move the C to the other side. So you guys should have added 9 on both sides and gotten this. Any questions so far? Okay, go ahead and do step 2. Now, I'll warn you about step 2. We're factoring out the A. What's the A here? Negative. So you're dividing by a negative. That's going to change some signs. So watch out for that, okay? So on this step, step 2 was to divide out the A. So to divide the negative 4 out. So negative 4 divided by negative 4 leaves us with a positive 1x squared. And 8 divided by negative 4 leaves us with a negative 2x. So it changed that middle sign. You got to watch out for that. That negative is going to affect something else that I think, who was that? You asked about earlier. It's going to affect that 4th step. All right, let's go ahead and do step 3. What do I write? Plus what? 4? Okay, so you had the right idea. We do want to add a new number here, but I don't think it's going to be 4. So what we do is we take half of the middle number, which is what? Negative 1, and then we square it. What is negative 1 to the 2nd power? 1, right? So I think it's just going to be 1. Okay, but you had the right step in mind. We are putting a number there, right? All right, so now I want you guys to go ahead and do step 4. This step is to fix the balance. We added something on the left side, so we have to put something on the right side to keep the balance. Now, by putting a 1 in here, it's actually being multiplied by negative 4. So by putting a 1 in here, we actually subtracted 4 from the left side. And since we did that on this side, we're going to add that value over here. So I'm thinking of it as adding a negative, but it's the same thing as subtracting. Okay? So there's that. Now, go ahead and do the next step. Step 5, I guess? Yeah, so you're adding, or you could just say subtracting, right? Because if you add a negative, that's the same thing as subtracting. Move the K. The K is this number. Yes, I am. Thank you for noticing. Steve, what'd you get?
3 or 4 x minus squared minus 5 equals 1.
There you go. Final answer. So now we've got it in vertex form, which means that we can see our vertex, we can see our A value that tells us the direction and stretch value of the function and whatnot like that. So there you guys go. So that was a guided practice, and it doesn't have to take that long. I just wanted to give everybody a chance to think before we did each step. But let's have you guys just do one completely on your own now from beginning to end. Oh, is there only 2 minutes of class left? You guys can do this in 2 minutes. Easy. Are you sure the bell's going to ring in 2 minutes?
I hope so.
Okay. Thank you.
Really pull it out of the
Have a good one.
Thank you.